Kirk Math. Hey there, ladies and gentlemen. Here we are on 9.3 rotations. So in this video, you're going to learn how to rotate a figure given a description and write the algebraic expression of the rotation. So in the past, we have now learned, this will be our third transformation. So as a reminder, transformations are when we slide, move, flip, rotate, or grow or shrink a shape, an object, okay? We have learned translations. I know it looks familiar to or similar to this word, but a translation is a slide. Okay, we've learned reflections, and that is a flip. And now we're going to learn rotations, which you can probably guess would be a turn of a shape. If I can turn the shape, it's a rotation. Okay, so here we go. So take these notes really quickly. We're going to write these down. I will say this right here is going to be very important. All of these, the algebraic representations or equations are super important for you to memorize because rotations is a little bit trickier than all the other transformations, and using these algebraic representations will be a lot easier than trying to physically rotate it and count it on the coordinate plane. Okay, so we're going to start by going over a rotation. So a rotation is a turn, and we are turning around a point of rotation. That point of rotation is almost always going to be the origin. Okay, in 8th grade, we rotate about the origin. In geometry in high school, you might learn how to rotate around different points, but for now we're going to rotate around the origin, okay? So as you can see here, my original shape, C, if I were to kind of connect this to the point of origin, here, if I were then to turn, and like if this was something, you know, an extra piece of paper that's on there, and then I pushed and turned this, keeping this point the same, I'm going to rotate my shape and it will turn to look like C prime here, okay? That is our rotation. So when I rotate it, it's going to end up looking like this. And you can tell because my little lines here are kind of touching the same points of that shape. So as I turn it, it'll kind of turn and look like this, okay? Your center of rotation, like I said, is the point where the figure is being rotated. It's going to be our origin for now. And so you're going to write down these. We're not going to talk too much about these points yet until we do an example, but I do want you to know that counterclockwise is usually the more dominant description when rotating something. So if it just says rotate at 90 degrees, it's talking 90 degrees counterclockwise. If it says rotate at 90 degrees clockwise, then it's talking about clockwise. So we probably need to know what is clockwise and counterclockwise. So if I have a circle here, okay, and the top is 0 degrees, that's where I'm starting. Clockwise would be to the right. So this is clockwise to the right. Counterclockwise will be to the left. Okay, so that's why over here we say that 90 degrees clockwise and 270 degrees counterclockwise are the same thing, because if I go just a fourth of a turn, a right angle here, 90 degrees to the right, it's the same thing as going 270 degrees or 3/4 of a turn left. Okay, so you can kind of see here that this is 90 clockwise and this is 270 counterclockwise. Okay, then I have the same thing with 90 degrees let's do the same orientation here for this. Okay, if I turn to the left 90 degrees, that's the same as 270 degrees clockwise. Okay, And then 180 degrees is just 180 degrees. It doesn't matter if it's clockwise or counterclockwise because it's directly across from where our starting point is. Okay. All right. Let's go ahead and start looking at an example here. So, like I said before, there's a way to kind of count points and then count points and graph these points, but it gets really confusing, especially when you're doing like 270 and things like that. So instead, we are going to use this information here. Actually, hold on a second. All right, so I went ahead and grabbed the graph or the table here from the other page so that we can see what we're working with, okay? All right, so we are going to use the algebraic representations here to demonstrate what's happening to our shapes, okay? So in this example, we want to rotate it 90 degrees clockwise about the origin. Now, about the origin just means around the origin. So the origin's going to be our turning point. It's like if I put my finger here and twist this around, this is going to stay in its place, okay? So bear with me. I'm going to do some color coordinating so that you guys can see, but basically we are going to use 90 degrees clockwise, which is the same as 270 degrees counterclockwise. We're going to use this one right here, okay? So this is the algebraic representation we're going to use. Okay, so we are going to look at the points of B, C, and A, original, and we're going to translate them, or we're going to rotate them and use this algebraic representation to turn them into B prime, C prime, and A prime. Okay, that's what we're going to do. As you can see here, this is our original organization of our ordered pair with X first, then Y. And what I'm going to do is flip the X and the Y and make the X the opposite sign, okay? And I'm going to show you that a couple times, and we're going to do that a lot in this video until you kind of get the hang of it, okay? So first I need to identify what's the X and Y of each of my original points. So B is -2, 3, C is +2, 3, and A is at our origin, 0, 0. Okay, so I color-coded them here with our original X values being green and our original Y values being purple. And what I'm going to do now is for each shape, I'm going to flip-flop X and Y, and then I'm going to take the original X and I'm going to change its sign, or I'm going to make it its opposite sign. So this -2 will become positive, okay? Okay, so I did the very first step, which I flip-flopped my X and Y, so you can see that my B prime is now 3, -2, and my C is now 3, +2, and A is 0, 0. So now I just have to do this last part, which is change the sign of my original X value. So my 2 will become +2, my +2 will become -2, and 0, well, I can't make 0 negative. It doesn't have an opposite, so it gets to stay itself, okay? 0, think of it this way, changing the sign is really multiplying the number by -1, right? -1 times -2 made +2. That's how I changed this 2 up here. -1 times 0 is still 0. So that's why the 0 is still 0, okay? So now that I have my new points, I can now plot them, or in this case, double check them on my graph. So here B should be at +3, +2, so that one checks out. C should be at +3, -2, that one checks out. And A should still be at 0, 0. And then the last thing I have to do is just connect my points. So I'm going to connect A, B, C, and I'm a little wide and wonky because of the way I'm drawing, but you can see now that this triangle was now rotated 90 degrees to the right, clockwise. Okay, so we're going to try this again. So now we're going to rotate this triangle at SBL 90 degrees counterclockwise. Okay, so that's down here, 90 degrees counterclockwise. So we're really going one to the left. Okay, that's where we're trying to go. So I need to use this algebraic representation here. So I need to remember that 90 degrees counterclockwise is negative y x. So I'm flip-flopping x and y again, but this time instead of making x negative, I'm making y negative. Okay, so we're going to start to write this out. So first we're going to write out the coordinates for S, B, and L. So S is 2, 2. B is 1, 2, 3, 4, 5. And L is 5, 0 because it's not off of the y axis. Okay, so I'm going to write those in. Okay, now what I'm going to do is I'm going to flip-flop my x and y. And I'm going to turn the original y into the opposite sign. Okay, so the 2, and this one's pretty easy. 2 and 2 flip-flop, that's still 2 and 2. And the first 2 here will become negative because it was positive, right? Flip-flop them, this 5 will turn negative. Flip-flop them, 0 is going to stay the same because it can't go negative. Let's write them in. Okay, so you can see here, I flip-flopped the x and y, and then the original y value has changed signs. I flip-flopped x and y, changed signs. Same thing here, but 0 can't change signs, it just stays 0. Now what I have to do is I actually have to graph these points on my coordinate plane so that I can see that 90-degree rotation. And because we know, whoopsies, where'd it go? Because we know we're going 90 degrees counterclockwise, I know I'm actually going to rotate, and my new shape will be in this next quadrant here, quadrant 2. Okay, so I am going to graph them. Let's see, S is at -2, +2, so that's here, that's S prime. B is at -5, sorry, +4, I was looking at the wrong one. That's B. And L is going to be at 0, +5, which is here. So that's L prime. Now I connect my shapes, and you should see that this first shape is still congruent or equal to this shape. Oh, that reminds me, back here we forgot to write this down. Is this figure congruent? When we rotate, does our original pre-image, is that the same size and shape as our new image? Now, just because they look different doesn't mean that they're the different sizes or shapes. Yes, these smiley faces are the same size and they're both still circles. However, so yes, it does preserve congruence or congruent. Ooh, I don't know what that was. But no, it does not preserve orientation because my smiley face rotates and turns to the side. So it's not facing the same direction anymore. Same thing here. This guy is rotated and is a different location, but is the same triangle. Okay, this next example, we're rotating 180 degrees. 180 degrees, it doesn't matter which direction. And the formula we're using is negative or opposite sign of x and opposite sign of y. So my x and y don't flip-flop. They just both change signs. So here's my v, s, and g, and I'm going to go ahead and just change their signs. All right, so I changed the signs of all of my x and y values. Obviously, 0 doesn't change signs. And here's my original shape, and then you rotate it 180 degrees, and it flips upside down on the other side. All right, on this one, it's another 180-degree rotation, so we're just changing signs of our x and y. So you can see here, we go changing signs. If they were negative, they're now positive, okay? And we would rotate this triangle over here. This is actually a duplicate. You don't need to worry about that one. But I would go ahead and see if you can figure out this independent practice one on your own, doing a rotation of 90 degrees clockwise about the origin. Okay, remember, these little things right here are key. That's important.